Okay.
Yep.
So today we are going to see very insightful session about how to create a multi-agent creative blogger with Azure. Concretely with semantic kernel, we will see also some services like Azure AI Agent Service and Azure AI Search. So we can combine different Azure service to create a multi-agent creative blogger. So the goal of this multi-agent creative blogger is create a blog post. Okay. So they are combining of 4 agents. The first one will do a research on the internet, random by Bing search. The second one will find products on a AI search database. Just because this creative blogger is intended to create a blog post to do a cross-selling product to incorporate to the post products from the company, so you can do a cross-selling in the post. And then there is 2 more agents, the writer and the editor, that will do a conversation of in which the writer will create a draft and the editor will review that draft, provide feedback to the writer, and then back and forth we'll create new draft, new feedback until an agreement is completed. We have also a termination strategy. We will see all this in the code later on the session. Just before starting, I want to present myself a little bit more deeply. I am David Lorenzo. I work as a Power Platform lead in Propware. You can scan here for applying to Propware just in case you are interested. I am mostly active on LinkedIn. Here is my profile. I am also on Twitter or X with this profile. You can reach me both social network. I usually try to apply to Microsoft certification. I currently have a Power Platform Solution Architect, Azure AI Engineer, and Fabric Analytics Engineer Associate. These certifications are very interested in my field because I usually work with Power Platform, Azure AI, and also I do iterations mostly with Fabric. Although in where we have a Fabric or data specialized team. And I also lucky to have the MVP award on the Power Apps category. And just finally, I want to recommend you to subscribe to our channel in Warandinga Tech. This is Spanish content, okay? But you can also use translation, or you can also try to learn Spanish as much as I learn English to have this session away also. All right, so let's start. So an AI multi-agent system consists of multiple agents that interact and collaborate to solve complex tasks, share information, and achieve goals both autonomously or semi-autonomously. So in today's session, we will see 4 agents that will make a blog post or a complex task, and then they do it semi-autonomously because we will give their initial instructions. Okay, so that's semi-autonomously because we make like the trigger to start the process, and then they told to each other to finish the process. But of course, you can make agents to operate autonomously based on trigger, based on whatever event you configure. Okay. Okay, what an agent needs to accomplish 3 main things. Okay. First of all, he needs to reason over a provided business process. In this case, we will give the first agent instructions to find information about the topic. Then it needs to retrieve context to complete the process that the first and the second agent, the first one will go to Bing and search information on the internet about the provided topic, and the second one will find related products. Both retrieve context for the process. And then the agent need to perform an action for the end user. What is this action in this case? To write a blog post and to review the blog post and until they reach an agreement, and then give that blog post to the end user for the reviewing. So I just recommend also never, for this moment in which in this AI epoch we are, we don't want the AI to create a blog post and publish directly to the internet. We want a human in the loop as much as possible. All right, so let's go forward, and we have here a good slide to see the evolution of LLM-based solution. In this case, we start from the left to the right, in which we have before AI, we have like no agent section. We have like a chatbot to complete a summary of the document. That's an example. Of course, a chatbot could do more things, but the initial AI haven't called agents. It was called like chatbot, and then you can make a RAG process of giving a document, giving a prompt, make a summary of the document. Of course, you can do more things. Then we evolve to a single agent, in which we have one agent that does a lot of things. Okay, we can plug functions, plugins, different integrations, but everything was in the same orchestration engine for one agent. Okay, so we make a question, the agent will try to activate plugins, activate knowledge source, do whatever thing it was programmed to do, and then combine that context with the LLM, with the prompt, send to the LLM, and give it an answer for the user. Okay, but this was okay, but has some problems, because one agent that does a lot of things incorporate a problem in which they are hardly to test, they are hardly to divide in different developers groups to extend the functionality, because they will conflict the development from one group to another group by working in the same agent. So it has a lot of problems. And then we evolve to multi-agent system. Before explaining that, if you come from the developer world, from pro code, like me, you remember the monolith application and the microservice application. So this is a similar approach. We evolve from single agent application that has a lot of functionality in the same agent to a multi-agent application in which we have like every agent have a single responsibility, is much easier to test, is you can assign the develop and test of every single agent to different groups, and then create an orchestrator to the multi-agent system. Okay, as we will see today that approach. Okay, in this multi-agent system, what we have is, as I mentioned, single agents that does every agent does specific things, and then we combine this and coordinate with using a coordinator agent, using also different orchestration patterns that I will show you in a moment. That is very interesting article that Microsoft have launched just a month ago, and I recommend also taking that into account when developing this multi-agent system. And of course, we can add memory functionality. We can have different proxies or different coordinator agents to decide which of a specific agent have to take in place for every question of the user. All right, so then as you can see here, we can have that every agent will query different data source, different APIs, different functions. And so we can test that much better using different developer groups. So that's one of the advantage, and the recommendation, of course, is to evaluate every case. We don't have to go every time to multi-agent system. We don't have to go every time to single agent system. As the same way, we don't need to go every pro code developer to a microservice approach, and also we don't need to every developer system to go a monolithic approach. We need to evaluate each of the project, each of the business case, and then decide on which is better for us. All right. Okay, so in this case, today we are using Azure AI Agent Service, which is a good Azure service that is just getting better and better. It was GA, I think, on May or June from the build Microsoft build dates. And then we can use for the moment with pro code orchestration. So we need to use semantic kernel, for example, to orchestrate the agents. But in these days, Microsoft is launching also the low-code approach orchestration, in which just inside Azure AI Foundry, we can create the orchestration patterns. We can create, if you remember here, we can create this coordinator agent, and then add specific agents to this one, and create like routing and orchestration patterns to decide which agent have to intervene in the process, and in which order, and so on. So some of the features of Azure AI Agent Service includes rapid development and automation. So we are evolving from pure pro code to more low code experience, in which we have some knowledge source, some data source, some integration already plug and play ready to connect. We can connect to data connections. We have flexible model selection. Of course, we can let every single agent a different model, depending on the features on the needs. That will give us more flexibility and more cost saving in our process, because we can have like, for example, for one agent that we need to enable deep reasoning, we can put like GPT-4o or GPT-4.1, and then we have another model that just make a summary. We can put GPT-4o mini, and then we can save a lot of money in token consumption, just having this flexibility. And then we have the enterprise grade security, which I want to go deeper, because this is very important. We usually focus on the just the business case, the features, and we don't get too much look at tracing and monitoring. For example, you create an agent, you create a multi-agent system like today, and then you need to, of course, go to production. You are testing, you are okay, everything is working, you go to production. Users start using the multi-agent system, the chatbot, and things start to fail. What is happening? Oh, I don't have enabled tracing and monitoring, so I can't check that. So this is very important to have in mind since the beginning of the architecture process, to have a good tracing and monitoring system. Also, we can enable content filters depending on our use case. For example, in our use case, it's very good to have content filters, because we don't want to create blog posts that have harmful content for the community. Okay, then you can bring your own storage and search. You can, of course, connect the securely way. You can create VPNs between your Azure AI Foundry agents and your your storage and search, and then you can of course use managed identities to make a keyless setup and authentication, giving all the Azure security power to your multi-agent system. That's very interesting. It's not the focus on this session, but it could, of course, have content for 1 hour session on this, just focusing on these features of enterprise grade security. So I recommend you, if you are developing with Azure AI Agent Service, you specialize and read and learn content about these 5 features. All right, so as we mentioned before, we are evolving from a single agent approach to a multi-agent approach. And then we are to orchestrate the multi-agent system, we can use AutoGen or semantic kernel. Both are Microsoft libraries, but of course, Microsoft is recommending semantic kernel for production ready and stable system. But you can use AutoGen for the state-of-the-art research. So you can start exploring AutoGen and seeing what is the state-of-the-art on orchestration and multi-agent orchestration. But of course, the Microsoft recommendation is to use semantic kernel for production-ready system. And here is the definition of semantic kernel. It is a lightweight, open source, production-ready orchestration middleware that lets you easily add AI to your apps. Okay, we will see it in execution in playing today. In the session, I will show you some code which use semantic kernel, but of course, you need to know that you are not tied to C#, you are not tied to .NET. You can use Python or Java also with semantic kernel. So this is good because Microsoft is not married with .NET, and this is good because more community are using semantic kernel, so it will get more improvements and benefits from the community. Okay, and then if we look at which features you can plug into semantic kernel. So you can start from the top left corner using AI services like Azure OpenAI, OpenAI itself outside Azure. You can connect Gemini, you can connect DeepSeek, Hugging Face, NVIDIA services also. So it is very good on having this flexibility here. We can also connect local models, just in case we have a powerful GPU in your house or near our company. You can use Olama, LM Studio, or another engine for running models locally and use your own GPUs to do the inference. We can add also memory services. Today we are using Azure AI Search, but you can use also Elasticsearch, Pinecone, MongoDB, Redis, and so on. This will add memory, like you can just keep user settings, like to have a more personalized agent, or you can add also context for your rack pattern creation. We can use agent service. We are using today Azure AI agent service, but you can also, sorry about that. You can also use Bedrock, AutoGen, Creo AI. We can connect plugins or functions, depending how you call it. You can connect MCP servers, OpenAI functions, container apps, logic apps that will extend and give more power to your agent. For example, remember that an agent is querying a neural network that is trained with specific data. So, for example, one simple thing as just knowing which hour it is in a city of the world, you can't do it with an LLM. You need a function applying our MCP server that will connect to a real clock and get the date and time. So that's very interesting because you can easily connect these plugins, define the script what is the use, and then the semantic kernel will create a plan for you when you run a query, and then try to guess which MCP or functions it should use to respond your query successfully. Then you can use prompts, different prompt system. We are using today YAML prompts, but you can use also semantic kernel prompts. And then you can add, of course, remember from monitor and performance, you can add Azure Monitor, OpenTelemetry is the standard used in semantic kernel, and then you can connect an Aspire dashboard. I will show you today an Aspire dashboard connected to the system, which is very useful to just debug your queries, okay? So here you have a lot of features, and just going to the last slide before we jump into the demo. We have here the multi-agent blogger architecture, which is, as I explained before, is a 4 agents architecture system, which the first one will do research on grounding within, and it will get the information from the internet. The second one will make a query to Azure or to Azure AI Search and find related products to the topic we have provided. The third one will write a blog post. We will see now the different prompts for these agents. So we here give some instruction on how we want the post. We give length instructions, different format instructions, the section it should have, all these type of things. And then we have the editor agent, which will analyze the post, and they, of course, have some instruction on where to check and how to check, and then it will provide feedback to the writer to write a new draft, and then it will iterate 2 or 3 times until an agreement is reached. So that's all published on a container app. I show you now the Azure resources. So we have the Azure Container Apps connected to the Azure Monitor. Here we connect the Azure Aspire dashboard, and then we have a simple front end on another container app, and then so that's the main architecture. Of course, we have Key Vault in the back. We have managed identities. We have Azure AI Foundry. All this stuff that goes behind that, but this is the functional architecture I want to show you. And let's demo. As I promised, let's go here and jump to the demo. Okay, let's start by going to Azure, and I want to show you the resource that we have. Okay, so we have this RG Creative Blogger Writer. This is the resource group, and inside this we create all the stuff that we need for our demo. So we have a container registry where we upload our container apps to keep the different versions and to deploy to the container apps environment. We have container app for the front end, another one for the backend where the Aspire dashboard is and the API is located. We have bin resource where we are plugging this to one of the Azure AI agents, which is the research agent. With this bin grounding, we are providing powers of internet search to our agent, so we can find the latest information about the topic. We are going to need also an Azure AI Hub, which contains an Azure AI project in which our models are deployed, and our Azure OpenAI service is deployed also. And then we have a key vault where we store some of the keys for the different service. We have managed identity that gives connect the permission between all the services. Log analytics workspace is where all the logs or the telemetry is kept, is saved. And then on the second page, we have Azure OpenAI, and we have a search service and a storage account to make the product indexation and so on. So that's all the Azure services. And then I think that we can jump to the code. And I want to show you some, okay, let's do one thing before jumping to the code. We are going to launch the demo. Okay, so this is the interface. We have here the chatbot text box, and then the working system is so the working way is we need to provide instructions for every agent. So if you remember, we have 4 agents. We have a research agent where we are going to do some Bing search on the internet, and then we are telling, can you find the camping trends in 2024 and what falls are doing this winter? Okay, so with this instruction, he goes to the internet and just take some information back. Then for the products, we request for can you use a selection of tents and sleeping bags as context, and then writing. We give writing a fun and engaging article that includes the research and product information. The article should be between 400 and 600 words. So if we copy these 3 instructions and we put it on the chat box and we hit on send, it starts the process by going to the internet. The first agent will write here the research process. Then the second will try to find products. In this case, no matching have, but it provides some product hints here. And then we have the writer agent to write the first draft, which is this. The editor agent have provided the feedback, review feedback, and then with this feedback that states that, for example, the title "Damn Me Away Discover blah blah blah" appears to have a typographical error. The word "damn me" should be corrected to make the clear, you know. And then here you see that the second draft is different title. The section top year for your 2024 campaign event should specify the brand of source of the mentioned product for credibility. Ensure consistent use of the verb tense throughout the article. There are instances of shifting between past and present. Okay, so with that feedback, we provide all the context for the editor again, for the writer again. It writes a new post, and then the editor agent will say article accepted, no further reward necessary. So I want you to remember this article accepted word, because this will be our termination strategy. So when you are doing multi-agent system in which there is a loop between several agents, in this case we are using I want to point you to the correct name. The correct name is a maker checker loops. I will go to this later on, but I will you to remember this type of loops. So this type of loops in which 2 agents are talking to each other all the time needs to have a termination strategy. Termination strategy means that we need some way to stop the loop. So we have different options. We have like this type of messages in which we check the message content. We have also a maximum iterations a maximum of iterations, and of course we can have different termination strategy. In this case, we are trying to find the article accepted word in the editor agent feedback message, And then with this when this happens, our loop will finish. Okay. So we are now going to see the code, and then I want to explain you also the orchestration patterns here in this article. Okay. I want to put this on the chat just in case you wanna keep in your okay. Look, thank you for putting there. Okay, so let's go into the code. I have here the code. I will later on I will put also this repository, which is an Azure samples repository, in the chat box, so you can just download, deploy if you want to try and play with it. But I want to explain you the main part. So in the program, so the main project is the chat app web API. And then we have here several interesting files I want to show you. The first one is the program. Here we start by creating the Azure OpenAI client, Azure AI search. We add semantic kernel and add different Azure services like the Azure chat completion endpoint, the Azure OpenAI text embedding generation endpoint, and then of course we initialize the default services for a .NET app. Okay, but this is the main part for the specific of this project is this one. Okay, so the creative writer app is our starting point. So we go here every time a request is comes to the API. The injection dependency injection container will create an instance of a creative writer app and inject the semantic kernel object and the configuration. We have all the configuration for this application in a configuration file. And then we start by create a new session. Okay. In this session, what we are doing is to define the different agents. Okay, here we create an agent service. Okay, so we create a task, a thread is calling inside the agent service. In that thread, we will plug the 4 agents that our project will use. So we have the researcher agent. Okay. We are also using the prompts. We are not going to see every of these prompts, but remember that we have a YAML prompt inside semantic kernel features. So that way we can separate the prompt definitions from the agent creation, and we have more clean project structure. We create the researcher agent. Here we create a marketing agent and configuring with marketing YAML prompt. We create a writer agent, configuring with the writer YAML agent prompt. We create the editor agent the same way we plug the editor YAML agent prompt. So after that, we create a session. In this session, first of all, we instantiate the Azure AI agent service and create a new thread. In this thread, we will plug our agents. Okay, we create, first of all, we are going to get the research results from the researcher agent. We're doing here in this block of code, and we put the response of the agent in the chat box in the response area. So you saw it here in the first process that the researcher agent gives a response. After that, our pattern, our orchestration pattern will get the product agent or marketing agent going to Azure AI search and trying to find products. And it will respond also in the area. Okay. And then we are doing an agent group chat, which we add writer and editor agent. We are not to see now this orchestration pattern in a moment, but remember the name agent group chat. And here we are doing like a conversation between the two agents until an arrangement is done. And here, remember, I asked you to remember this article accepted word, because here in the termination strategy, we are checking that article accepted in the content of the response of the editor message to just finishing the loop and finishing the process. Okay, so that's all about the semantic kernel use, the Azure AI agent service use, and the orchestration pattern. Now, before jumping to the article, I want to show you the different templates that we have here. We have a researcher YAML template in which we describe this template. This is for internal use, but the main parts are input variables. We have feedback, description. So we have a feedback input variable. And this feedback is what we put here in the instructions for the research agent. This phrase will be plugged here into the template at runtime, and then we configure some things here. For example, here is the market code for being searched. If you are using Google search, for example, but you can put here the Google search language codes or whatever you need. And then here is the general instruction. So with this template, the researcher agent will go and execute the prompt. As we have the being grounding search service connected to the agent, it will go and find this on Bing and just giving us back the information, as you can see here in the first box. Okay. All right. So second agent is marketing agent. It will also receive a product context. This product context is this one. And then it will go and find products on Azure AI Search. This is simple instruction. The writer agent is the most complex one because it will receive variables, the research context. Also, it will receive the research results, the product context and the product results, and the assignment. Okay, so what is this? So the research context, remember, is this phrase. The research results is the response that we have in this box. The product context is this phrase, the instructions, and the product results is the results that come back from Azure AI Search. And then with all this, the assignment, of course, is this this instruction here. With all this at runtime, it will execute these prompts through the LLM and then getting back a draft. Okay, getting back a draft of a blog post, and then starts the loop between this and the editor. The editor will have all the conversation context and then it will check with this instruction, will check the draft and then provide feedback. Then with that feedback, it will back. And then here in the assignment, here we plug the feedback at the end, and then the new prompt with the feedback is feed again to the LLM, and then this is done a few times until the termination strategy is applied. Okay, so that's all the prompts. We have 4 agents, and this is the result. Of course, you can improve this by formatting better or adding HTML formatting or exporting. You can export this to the HTML. In the product search, you can improve also your product database, adding links to your product selling page. You can also use service depending on your company, but this is a good starting point. A good just project, template to start and improve depending on your needs. We have some minutes left. I want to show you this page. I recommend you take a look at this because this is a new article just a month and a half ago. Here Microsoft provide us with different AI agent orchestration patterns, which are very important to know the pros and the cons, are when to use, when not to use them in nowadays, because the multi-agent systems are here to stay, and we need to know in the architecture phase which pattern is better for our use case, because in the end of the project it's difficult to change it. But if you think about it on the design phase, you will get a much strong approach, a much strong system where you can scale and evolve during the lifetime of your product. So we have first of all the sequential orchestration, in which the different agents are called one after another. This is, for example, for I know you have for each pattern you have when to use and when to avoid. All right, and then you have a sample here, allow firms document management software. Okay, that where you need to get some information in different stage, and then different agent needs to check that information and sign, approve, and so on. So it's a step-by-step phase. This is a sequential orchestration example, and you have here, this is one of the most important parts. In every of the patterns, you have when to avoid and when to use. So this will help you to make a decision as an architect. Concurrent orchestration. This is where you can parallelize different tasks for different agents to improve the speed of the overall process. And then, but of course, if there are dependency between stages, you can't do that. So that's why you have again here when to use, when not to, when to avoid. And an example, it could be a financial service firm that build an intelligent application that use concurrent agent that specialize in different type of analysis to evaluate the same stock simultaneously. Okay, or for example, in trading or in sports bets, where you can evaluate the bet benefits from different providers and then make a decision on which one to buy or which one to sell. All right. So that would be a good example. And then we have the group chat. This is, you remember this word in our code? So I can show you again, group chat. So this is our pattern. In this case, we have a group of agents that will make a process, and we have also maker checker loops. The maker checker loops is inside the group chat pattern, and this is a specific type of group chat organization where one agent, the maker, in our case the writer, creates or proposes something, in our case the blog post draft. Another agent, the checker, in our case the editor, provides a critique or feedback for the result. So this pattern is iterative, and we need to put, of course, the termination strategy. All right. So this is good for different use cases, and our case, create a blog post is a good example of that. We are the hands-off orchestration, which enables dynamic delegation. And of course, this task, each agent can access the task at hand and decide whether to handle it directly or transfer it to a more appropriate agent. So when to use, when to avoid, and a pattern sample will be a telecommunication customer relationship or CRM solution that uses handoff agent in its customer support web portal. So there is an initial agent that tries to help the customer, but if the customer is needing more specific help, it will transfer to another agent more expert in that area. That's a normal, for example, the Microsoft support works like that. You start with level 1, and then if the level 1 can't give you support, it will transfer to a more premium level or whatever it needs to until it reach the product group if it is a bug. Okay, so that's a good sample for a handoff pattern. And then we got the magentic orchestration. It is designed for more open-end and complex problem that have tools that make direct change in external system. You can use this for example, for making documentation, or for example, to make handle low-risk incident response scenarios when there is a service outage or whatever you need. So you can use it for different tasks. I think it's not so popular like the first 3 ones. I think the first 3 of the first 4 are the most popular here in mostly of the system. And you have also different considerations. Okay, reliability, the context window, the routing is very important. You see all the GPT-5 routing problems that have on the launch. So this is some of the problem we are learning to these days, yet learning to use this. Of course, this article is only 1 month and a half old, so that way you can see that we are all the time learning. You have fresh information on Microsoft Learn to have to improve the knowledge and to have the best decision patterns for your architecture. And okay, we are finishing. I want to go back here and just put in you the code. You can grab the code here. I will copy, or let's check. Maybe look. Have you copied this on the box?
I have not. We
okay.
do have a question in the chat as well.
Yeah, sure.
Particularly, it looks like it might be around model deployments, but the question was, I read that the AI agent service several weeks ago. I read about the AI agent service several weeks ago, and I've had to discard it because the models available to use were deployed in Europe. Were very limited.
Yeah.
Could you mention what limitations the AI agent service has?
Yeah. So the model are deployed in the region that you choose between. So of course, among the regions that they are available. In my case, I can show you again the Azure screen. We have everything is deployed in East US 2. But of course, Azure OpenAI is not available in all the regions. So you have to check when you want to deploy the service. You choose you choose here Azure OpenAI, and then create. And when you create that, you have the region here. These are the available regions for Azure OpenAI. And inside this service, you deploy the models. So if you deploy the Azure OpenAI service inside, I don't know, France Central, then all the models that you deploy will be in France Central. Okay. So there is, I think, also in UK, in India, Africa. So I think there is in all the world, but I don't know where your location is. Of course, here we can open the model summary. You have here also the different models and the regions where they are located. Thank you, Luke, for that. And I think there is information about this in Microsoft Learn or in Azure OpenAI. Yes. Okay. I don't know if there is more questions.
No, nothing
I
here.
think no.
No, just to finish off, what resources would you recommend for people wanting to learn? Like they've heard about this for the first time today. Where would they go to learn a bit more?
Sure. I will give you Spanish lesson here. Muchas gracias, which means thank you for attending the session. Here again my contact details. You can add me here on LinkedIn with this QR code. And for the learning process, what I will recommend, depending on the profile you have, so the agent system can be created with pro code like this one or with low code, in which case I recommend to use Copilot Studio. So I will start by giving you some links for the Copilot Studio trial, which is try Copilot Studio, if I don't remember mal. But let me copy that with this link and business account. This is important. You can create a trial tenant and start using it. About this Copilot Studio, I recommend some YouTube channel. Let me try to find here and just put it a link. So I recommend some of the colleagues that
Awesome. I just want to end by saying thank you very much for coming, presenting, sharing your knowledge with us today, David. Giving up your afternoon, very informative. So thank you and coming to present.
So I will recommend this channel for Copilot Studio.
Lisa's great.
Lisa. Also, there is another ones, but you can find it on on YouTube. And just last point, if you want to go different learning path on AI, on agents in Microsoft, I would recommend to go to Microsoft Learn browse. I think it was here. Yeah.
There is a semantic kernel applied skill as well.
Yeah. So you can go this page and browse for different credentials. And then, for example, if you find AI here, this is apply skills are also here. For example, this one. Okay, you go to the page and then you have here all the learning path that you must follow in order to learn the contents that you need to approve this skill. Okay, so this is a good starting point for learning with Microsoft Learn. That's all, I think.
Awesome. Cool. Well, we'll end it there, but thank you very much for coming and presenting. And yeah, thank you everyone for attending. Hopefully you've learnt something. I definitely have. So yeah, thank you.
Thank you. Thank you, everyone.